We would need power on Mars for two primary reasons. The first is the astronauts need power for their habitat so that they can make oxygen, we can purify water. But prior to their arrival, we need to make liquid oxygen and propellant so that they can get off the Martian surface. Kilopower is a small nuclear reactor concept that is very simple and uses a minimum number of parts in order to produce power.
Power is the lifeblood of our exploration and expansion into space. The Kilopower system we're testing now is enough to power many ambitious deep space missions to the outer planets, to the moons of Saturn and Jupiter, and even out past Pluto. Kilopower is the result of lessons learned over the past decades of trying to get space reactors established. We went back and tried to make this system as simple as we could.
It ranges in size from 1 kilowatt, about the power needed for, say, a household toaster, up to 10 kilowatts. And at 10 kilowatts, we would use 4 or 5 of them on Mars in order to make fuel and to produce power for the habitat. It has a solid metal block of fuel that we fission that produces heat. That heat is used to heat heat pipes, which are tubes full of sodium metal that we boil, and that delivers heat to what's known as the Stirling engine converter. The Stirling engine converter is a simple heat device that uses temperature differential to make electricity. NASA chose Los Alamos to do the nuclear reactor design because of our long history with doing this type of work going back to the 1950s and 60s. We also have some of the world's leading experts in space reactor design. In the future, we want to take Kilopower to the next step. We want to test more of its reliability and its safety, and also do the types of tests NASA requires in order for a system to actually go into space.